friends, welcome to another video of Zeta Axis, and today we are going to discuss about Madden Julian oscillations, which is also called as MJO. Now here is a brief description of MJO, where we can see that MJO is an eastward moving pulse of cloud and rainfall near the equator that typically reoccurs every 30 to 60 days. So the important points that we should note is that it moves in the eastward direction, it occurs near the equator, and it has a cycle of 30 to 60 days. Some more description about MJO is that it is an intra-seasonal event. Intra-seasonal means that it can occur within a season. Like a season's length can be from 3 to 4 months, but an MJO is from 30 to 60 days. So within a season, we can have 3 to 4 MJOs. If we compare this with El Nino, so El Nino, it goes on for 6-7 months or even longer. So we can see that it is intra-seasonal. However, the MJO is intra-seasonal. That is, the El Nino will last for several seasons, while the MJO, it can occur within a season. It will start within a season and end in the same season. Then it describes it as bipolar. Now the bipolar means that the MJO has two distinct parts and they are opposite to each other. We will see it in the next slide. Here is a basic representation of MJO, where we can see that it has an enhanced part and a suppressed part. The air in the enhanced part, it converges on the surface and then rises up. The rising air will have some moisture. The moisture will get adiabatically cooled down, and because it cools, it will start as rain. So we can see that most of the times the enhanced part will have rainfall with it. In the upper atmosphere, the air will then diverge. So it will diverge in all directions. So here we can see that some of the air is moving in this direction, some air is moving in that direction. In fact, some air will move outwards while some will go in the backward direction. The enhanced part is accompanied with the low pressure system. The second part is the suppressed part. Suppressed part, we see that air in the upper atmosphere, it converges. This converging air will then descend downwards. Descending air gets adiabatically heated, and therefore we see that here there is generally dry atmosphere. On the surface, the air will diverge, and here we generally see a high pressure. So this is the basic meaning of bipolar, as we saw in the first slide. The bipolar means that it has two parts, enhanced part and suppressed part. The enhanced part is also called as convective or ascending part, and the air on the surface converges and rises up, as we just discussed. The rising air has moisture which is adiabatically cooled and gives rain. Air diverges in the upper atmosphere. Similarly, in the suppressed part, which is also called as descending or sinking part, air in upper atmosphere converges and sinks. Sinking air gets adiabatically heated, thus gives no rain. We see that there are no cloud formation in this region, and generally clear skies are seen in the suppressed part. Air diverges in the lower atmosphere or on the surface. Now this MJO, it divides the globe into two parts. In the first part, we see that there is enhanced part, and in the second part there is this suppressed part. So here we can see that there is a division. This side we have the enhanced part, and the effects of enhanced part can be seen in this region. And here there is suppressed part. So we will see drier atmosphere in this region. This is a map of MJO, and we can clearly see that in the middle we have this enhanced region, and on both of the sides, which is a continuous suppressed region. So we can clearly see that the entire globe is divided into two parts, enhanced region and suppressed region. Now this MJO, it starts to move in the eastward direction. Remember, the MJO begins from the west of Indian Ocean. It originates near this African coast, and then it will start to move towards the Pacific coast. So here we can see that this MJO, it will travel in the eastward direction towards the Pacific coast. Now when it reaches the Pacific coast, most of the times the MJO weakens over the Pacific Ocean. And the reason for this is that the Pacific Ocean water is cooler than the water in the Indian Ocean or West Pacific, which we can see in this diagram. Here clearly there are warmer waters, which we can see that red means warm water, while here we see that the water cools down. We see cooler water, means it is not cold water, but it has less temperature compared to these waters. And it is because of this the MJO will weaken over here in the Eastern Pacific. Now this MJO, which is moving in the eastward direction, sometimes it can re-evolve due to the hot water supplied from the Caribbean as well as Atlantic Ocean. And this is how the complete cycle of MJO is over. Here we can see how MJO moves along the equator and divides the globe into two parts. The region where there is favorable atmosphere for rainfall, that is the enhanced part is there, and the unfavorable region where the rainfall is low, where there is dry atmosphere. So we can clearly see how the MJO moves across the globe. Here is a summary of Madden-Julian oscillation that we have discussed so far. It moves in the eastward direction around the Earth. It completes one circle in 30 to 60 days. Every region faces alternate enhanced rainfall and suppressed rainfall region. And it develops in West Indian Ocean. So basically the MJO starts from the West Indian Ocean and moves over the Pacific Ocean. It becomes weak in Pacific Ocean due to cold water in the Eastern Pacific Ocean. It can re-emerge in the Central American coastal areas due to warm waters over here in the Caribbean region. And it also sometimes appears in the tropical Atlantic region. The MJO can occur throughout the year. Here we can see that the MJO, it occurs in winter as well as in summer. But the frequency in winter is higher, as we can see by these blue columns. And the frequency in summer is comparatively lower. So we can see that this is June, July, August, September, October, where the frequency of MJO is less. However, the intensity of the MJO is higher in the summers. That is, the air will move with much higher velocity. The impact will be higher for the MJOs in the summer season. Now let's see the 8 phases of MJO and its effect on Indian monsoon. Now before seeing the 8 distinct phases of MJO, let's first see the 2 important branches of winds which bring rainfall to our Indian subcontinent. The one in the yellow is called the Arabian Sea branch, and we can see that it comes from the Arabian Sea and it brings rainfall to the regions where it flows, and we can see all this Arabian Sea branch current in the yellow color. The second is Bay of Bengal current, and we can see the regions where this Bay of Bengal current brings rainfall. So here is the first phase of MJO, and we can see that in the first phase the MJO is formed over the Indian Ocean. Here the air from all directions will converge. It will come from here, it will come from here, it will come from here, it will converge on the surface and rise up. So in the phase 1, we can clearly see that the air is taken away from the Indian subcontinent. Therefore, it is definitely going to negatively impact the rainfall in India. And this is what is indicated by this map. This P1 indicates that this corresponds to the phase 1 of MJO. And the blue regions, they highlight the regions where there is more rainfall than the normal rainfall or normal average rainfall, which you can see by these colors. And the red color indicates that these regions have less rainfall than the average rainfall in the P1 phase of MJO. So we can clearly see that most of the regions which were receiving rainfall from the Arabian Sea branch, there the rainfall has reduced, while the regions which were receiving rainfall from the Bay of Bengal current, there is a relative increase in rainfall. Now here is the second phase of MJO, where the MJO is located in the central or slightly west from the center of Indian Ocean. It is just below our Indian subcontinent. Now here also wind will flow from all directions towards this region. However, we can see that over the Bay of Bengal there is slight impact of the suppressed part. Now because the air will move towards this, we will see a decrease in rainfall over the Indian subcontinent. And something very similar is also indicated over here. We can clearly see that all these regions, their rainfall is decreasing. However, there is some increase in these regions. And we have noted earlier that these regions are mostly supplied air from the Bay of Bengal branch. Now, in the third phase, we clearly see that the MJO has moved towards the Indonesia. It is in the eastern part of our Indian Ocean. here we see that the enhanced part lies over Bay of Bengal or just below Bay of Bengal. Now clearly in this part we can see that these regions have increased rainfall while these regions have reduced rainfall. Now this is not the exact mapping of the Arabian Sea current and Bay of Bengal current, but we can see some correspondence in the region. We can see that these regions where the Arabian Sea branch supplied rainfall, it has increased now. In the fourth part, we see that enhanced convection reaches the maritime continent, that is Indonesia and West Pacific. So we can see now it is lying over these Indonesian islands and West Pacific. And in this phase, we will again see that there is a further increase in the amount of rainfall which was coming from this direction. There is also increase in this region. So we can see that overall there is increase in the rainfall in the phase 4. Now this MJO, it further moves away and it moves in the Western Pacific region. And now we can see that all over the India, we can see that there is increase in the amount of rainfall. There is some enhanced part over the Bay of Bengal, and we see that there is some decrease. Now it occurs because in the enhanced part, the air will move towards the center, and therefore the air will move away from our Indian subcontinent. Therefore, there is some decrease in rainfall over here. Now in the sixth phase, we see that it moves further eastward over the Western Pacific Ocean. And now we can see that the rainfall region has expanded. In the phase 7, we see that the MJO is now moving towards the Central Pacific region. We can see that the enhanced part is over here and the suppressed part is over here. But we see that enhanced part's effect can be seen over here. So because of this, we will see that there is again decrease in the rainfall over most of the part of India. In the phase 8, the MJO has moved further east in the Pacific Ocean. And now we will see that there is large scale reduction in the amount of rainfall in our Indian subcontinent. So if we look at all the phases of MJO, then we will see that the phase 1, 2 and 7, 8, the MJO will reduce the amount of rainfall in India. And in the phase 3, 4, 5 and 6, the MJO will increase the amount of rainfall in India. But if we take the whole duration, that is the 30-day cycle or 60-day cycle, then remember, for most of this cycle, there will be break events in Indian monsoon. That is, there will be no rainfall in Indian subcontinent, while in the active monsoon duration will always be less than the overall duration of these break events. The active monsoon duration indicates the time when there is increase in the rainfall due to MJO. This is a diagram which is used to represent different phases of MJO. Here we can see phase 1, 2, 3, 4, 5, 6, 7 and 8. And here it is over Africa. Here it is in Indian Ocean, Maritime Continent and Pacific Ocean. These dots, they show the break event in Indian monsoon. And we can see that all these dots are concentrated on the left side where we have phase 7, 8, 1 and 2. While here we can see that relatively less number of break events occur. And if we see the colors of these dots, it indicates the duration of those breaks. So we can see that for all the breaks that occur on the right hand side, they are of less duration. So basically we can see that the Indian monsoon is reduced during these phases of MJO and it is increased during these phases of MJO. The MJO also increases the amount of tropical cyclones in Indian Ocean. And here is a percentage. This is for the active phase of MJO and this is for the suppressed or less active phase of MJO. So we can clearly see that when the MJO is active, the amount of tropical cyclones will increase in phase 2, 3 and 4. And if we compare them when there is less active or non-active MJO, we can clearly see a sharp increase in the percentage. So these phases, we can say 2, 3 and 4, here the number of tropical cyclones in the Indian Ocean increases. Indian Ocean means both Arabian Sea and Bay of Bengal as well. Now let's summarize the effects of MJO on Indian monsoon. So we have already seen that MJO, when it is in phase 3, 4, 5, 6, early start of monsoon. So monsoon will start earlier because it enhances the amount of rainfall in Indian subcontinent. There is increase in rainfall in monsoons and increase in the number of tropical cyclones also occur during these phases. We have seen in the previous slide that there is increase in the number of tropical cyclones when MJO is in phase 2 as well. So include that too in this. And when MJO is in phase 1 to 7, 8, we see that there is delay in the start of monsoon. So the monsoon will reach India a little later compared to the normal times. There is break events in Indian monsoon. That is, there will be no rainfall in Indian subcontinent for 2, 3, 4, 5 or 10 or 15 days. There is overall decrease in the amount of rainfall in Indian monsoon. These are these phases. Now let's see how periodicity of MJO impacts Indian monsoon. On internet I found these arguments. It said that if the period of MJO is 30 or less, then it will have positive impact on Indian monsoon, that there will be higher than average rainfall in Indian subcontinent. If the number of days is greater for the MJO, it is greater than 40 days, that is the MJO cycle is greater than 40 days, then there will be less rainfall during Indian monsoon season. Now the reason that they give for this is that if the MJO is of shorter cycle, then it will visit the Indian Ocean more often during the 4-month-long monsoon period of India. So more number of MJO active phase will occur and it will bring more rainfall to the Indian subcontinent. Now let's try to check this argument. So here on this x-axis we can see the 4 months of monsoon starting from June and 120 days till the end of September. Now if we consider an MJO has 40% active days, that is this is the period when there will be increased rainfall in India. So we can see here that for a 60-day cycle, which is there will be 24 days for active rainfall and 36 days for suppressed rainfall. So the total active days will come out to be 48 days in the 4-month-long monsoon period. Now if we take the 30-day cycle of MJO, here is the one cycle, and in this one cycle the 40% will come out to be 12 days. So 12 days there will be active rainfall and in the 18 days there will be suppressed rainfall. So over the duration of this 4 months we will again get active days of 48 days. Hence, irrespective of the period of the MJO cycle, the number of active days will remain the same. So I find it difficult to agree with this argument. So here is my argument. The MJO, it moves along the equator and it is mainly an equatorial phenomena. However, it impacts the regions which are in the extratropical region. Remember, India, the northern part of India is also in extratropical region. So in this paper, we will see that an argument is made that many studies have found that the MJO, which acts as a tropical heating source, remember the MJO hits the tropical region, it impacts the tropical region. It excites a Rossby wave that propagates in the mid-latitude and modulate mid-latitude circulation. The extratropical mean flow can modulate the MJO extratropical response. Rossby waves can grow or decay in different extratropical background flows. So what it is trying to say, that the MJO, which occurs in the tropical region, it generates a wave, that is the Rossby wave, which propagates both northwards and southwards in the mid-latitudes, and it impacts the atmosphere over there. Now here in this diagram, we will see impact of MJO under non-propagation circumstances, that is MJO is almost stationary. So we will see that these are the 3 regions and we can see the impact of MJO on these regions. Now, if the MJO is moving fast, we can see that the impact reduces, and this is mainly because the MJO will have less time to impact the regions which are far away in the mid-latitudes or in the extratropical region. The lesser the time the MJO will spend in the region, the lesser amount of Rossby waves will be created, and therefore the impact in the mid-latitudes will decrease. You can read this paragraph from that paper. And if the MJO is moving slowly, then large number of rosy waves will be created. There will be a higher extratropical impact of this MJO. So this you can think of like an iceberg moving in ocean along the equator. Now if the iceberg is moving slowly, then it will change the temperature of water in a longer distance. But if this iceberg is moving at a very high speed, then it will impact the temperature to a very short distance. That is what is the reason for short cycle MJO impacting less on the Indian monsoon and long period MJOs impacting higher to Indian monsoons. Now let's discuss the effect of MJO on global weather. We have so far discussed the effect of MJO on Indian monsoon. Now we will see how it affects the global weather. So MJOs are considered to weaken the trade winds. Now this is significant because over the Pacific Ocean, it is the weakening of the trade winds that starts the El Nino. So it is considered, it is under research to find the link between MJO and El Nino. So the MJO is considered or suspected to initiate El Nino. It also affects the intensity and duration of El Nino and La Nina phases. The MJO increases chances of tropical cyclones. We have already seen for the Indian Ocean that when the active MJO is there, the chances of tropical cyclones increases. The same effect can be seen throughout the world. The regions of the earth having enhanced phase of MJO, that is this phase where the air is rising up, it has higher chance of tropical cyclone formation. The ascending region, it favors formation of tropical cyclones, while the suppressed part, it does not support or it disfavor the formation of tropical cyclones. Now there is one important effect of this. If we see this diagram, this is the North Atlantic Basin and this is called West Pacific Basin, and there is an inverse relationship between these two regions. If there is higher amount of tropical cyclones in this region, then there will be lower amount of tropical cyclones in this region. And if there are higher number of tropical cyclones in this region, then automatically there will be a reduction in the number of tropical cyclones in this region. The MJO, the two phases of MJO are suspected for this. Now there is another phenomena which is called sudden stratospheric heating, which is impacted by MJO. In the sudden stratospheric heating, what happens that the polar air in the stratosphere, which is moving in the anti-clockwise direction, it suddenly weakens and then it starts to move in opposite direction. And the air, it will start to descend at a very high velocity in the stratosphere. Remember, this event occurs in the stratosphere. And because this air is descending at a very high velocity, the temperature increases. And this temperature increase can be 52 degrees Celsius increase, which means that there can be an increase in the temperature. If the temperature is -20, it could increase as high as till 30 degrees Celsius. So a significant increase in temperature occurs in the stratospheric air. The MJOs is also connected with this phenomena. The MJOs are suspected to be somehow linked with this sudden stratospheric heating process. This linkage is still in study, but data shows a connection between them. Thanks for watching the video. If you've liked the video, then do subscribe to the channel and share it with your friends. If you like what we are doing and support us, then you can use the UPI ID shared over here. Thank you for watching the video.